Thanks everyone for joining. Good morning, everyone. Uh, it, it- uh, we are group two. We are MLOpers, and we are presenting on chapter 4. So we are just going to introduce ourselves. Uh, can you move to the next slide, please? Yeah. So I'm Raksha. I'm a graduate student at University of Michigan. So here are my teammates.
Hey, I'm Sebastian, machine learning engineer at Databook.
Yeah, I'm Melissa. I'm a software engineer at Gap.
Yep. So we are going to begin the chapter 4. It's I'm going to talk about sampling and labeling methods that is mentioned in the chapter. So in the previous chapter, we saw how do we handle data in a system perspective. Now we are going to see how we are going to manage the data on a data science perspective. So to get into introduction to sampling in machine learning, let's understand what sampling is. So sampling in machine learning, it refers to getting a subset of data from the large data set. So that subset is called as sample. And real life analogy to give, when we go to a store to buy a fruit, we usually taste the piece of the fruit and then make a decision whether it is sweet or not. And when we make a decision whether to buy an entire lot of fruit or not. So in a similar fashion, even in machine learning, in many cases, when we don't have access to the entire real world data, we choose a subset. That subset is called as sample. And there are different techniques, methods of getting that subset from the large data set that we are going to talk in this chapter uh, in machine learning. And this chapter gives a detailed explanation about how we can use these sampling methods to create our training data. So can you go to the next slide? Yep. So yeah, so when talking about, now we've seen the definition of sampling, let's understand why sampling is necessary. So when we are dealing with training the models, the first thing we need is data. And we often see that either we have access to the all the data that exist in the real world, we might not have necessary resources to store it, we have memory issues, or due to health privacy risk, like in healthcare, we might not have access to the real world data. So we'll have to consider a subset of data, or we might have a subset of data that we want to test on a new model. We just want to experiment how it works with our subset of data, and we want to quickly experiment and see how it's performing. So due to all these reasons, sampling becomes necessary before training the data. uh, yep. Yeah, so there are types of sampling that is mentioned. We go by non-probability sampling and random sampling. Uh, so a detailed explanation is given about the types of, and there are different method that comes into non-probability sampling and random sampling. We'll go one by one. So first we'll go start with non-probability sampling. Um, Yeah, so as the name suggests, non-probability sampling, we are not using any probability techniques or methods to sample our data from a large data set. Instead, we are going to use some criteria, some information that we know, based on which we are going to select our subset to get our training data. So the different methods that are mentioned are convenience sampling, snowball sampling, judgment, and quota-based sampling. So convenience sampling, samples are selected based on availability. For example, in Twitter accounts, if we have, okay, uh, in Twitter accounts, suppose if we are going to scrape the data based on hashtags, which is readily available, and it is very easy and it is very speed, that you can get, and like suppose if you have launched a new product, so hashtag new product, you can extract or scrape the data based on that hashtag, which is very fast, and there is no probability technique that requires here. So then comes a snowball sampling, like with the same example, like scraping Twitter accounts. You select a legitimate Twitter account from which you start scraping data. Then you go on, like where the person follows, and then you go on sampling their data. So this is an example for snowball sampling. So judgment sampling is like you are a domain expert for certain use case. You already know what kind of subset is required or a sample is required. Based on that, you kind of do a judgment sampling. Then comes the quota sampling, where samples are based on predefined quotas without randomization. Like you are an example is survey response, like you already have a predefined problem statement, like I want 100 responses from a group of people, even without knowing the original distribution. Like you are having a predefined problem statement, like I require 100 responses from different age groups. So that is what is an example for quota sampling. This non-probability sampling does have some limitation, because when we are sampling based on certain criteria, we cannot generalize it to the real world entire data. It might be a biased data, especially when you are just selecting only few based on certain criteria. So definitely your data is going to be biased, and it is
So
commonly.
Russia, yeah, this one like maybe you can move on from this because quota sampling is less used in machine learning.
Yeah, yeah,
So yeah.
yeah, yeah. We can move on to the next. So there are many examples that are mentioned for non-probability sampling, especially for language modeling. The data is available like Wikipedia, Reddit, so you can collect the data and start using it for your use case. There is sentiment data analysis use case where you can get data available, like it's an inconvenience method, like IMDb and Amazon reviews. So you can get reviews of people who have given reviews. It might be biased, but you will get some data. And an example would be self-driving cars. uh, the data collection focuses on the areas with favorable conditions. Like you might have a lot of data where there is a sunny weather, for example Bay Area and Arizona, and you might not have much data that locations where there is snow or rainy conditions. uh, Next. Yeah, so we have seen the non-probability samples based on criteria and their limitations. The other type of sampling is random sampling method. So when we're talking about random sampling method, there are certain types that are methods that are mentioned in the chapter. Simple random sampling, stratified, weighted, reservoir, and importance. So simple random, it's based on like simple random. The name itself is suggest like we are going to give equal probability for an entire distribution, like 10% of each class we are going to take and we are going to sample. That is one way of doing the simple random sampling. So you can randomly select 10% of the population, giving all the members of the population equal 10% chance of being selected. So there is a drawback in this method, is that it is very difficult to get the rare categories of data that might not appear in your selection. So to overcome this drawback, we have stratified sampling, where you can, before dividing or before doing the sampling, you can initially divide your population into groups that you care about. Then you can sample from each of this separately. So when you're going to divide initially the samples, there might be a drawback, like in case of multitask, a multi-label task, it's impossible for us to divide all the samples in groups. So
So
then,
sorry for jumping in. I think we assume that a lot of people read the book. So
yeah,
and so we want to like make sure that we get through the material. I know that you have a lot of great slides on content on the slide. So like
Yeah.
so this week we should maybe we try not going too deep into iterative sampling method.
Yeah. These are all the techniques that are already mentioned in the like weighted sampling comes, then the reservoir sampling. So it is useful, the reservoir sampling, because today we deal with a lot of streaming data. That is what is we see in our production. So reservoir is such one such sampling, because when you're dealing with streaming, you don't know the total size, which is that is incoming. The data that's incoming, the size of the data is unknown. Like for example, an example that is given here is uh, when you're talking about incoming stream of tweets and you want to sample certain number, like k tweets, and you want to do an analysis and train your model, and you don't know how many tweets are there, but you want to, and also you cannot fit so many tweets in your memory. So one solution for this problem is the reservoir sampling. So there is an algorithm, and it consists of 3 steps. So first you put the k elements into the reservoir, and for each incoming nth element, we are going to generate a number I such that I is less than 1 and less than equal to n. And
So Rasha, yeah, let's not go too deep into this.
yeah,
Yeah.
okay. Yeah, and another,
Same with this. Yeah,
yeah,
like yeah.
these are all the methods that are available for sampling. And talking about labeling, uh, labeling in context of machine learning refers to a process of identifying raw data, and we are going to annotate it with one or more meaningful information labels. So these labels is what allows us to learn, help the model learn and make predictions. And as mentioned in the chapter, it is very crucial for supervised learning. And the existing methods that mentioned at the time of writing of the book might be hand labels and natural labels, but there are new methods that are available right now for labeling. Yeah, we can go to the next. So hand labeling is more of like a person uses annotation tool to, annotate the raw data. For example, there are different kinds of data: image, speech, and text. If you take an image and you draw a bounding box in an image to identify the object, whether in an image is it a person, or if you're annotating for self-driving cars, so you draw the bounding box around the cars and say the type of the car, the color of the car, and many more details. So this is how an annotation is done, hand annotation, which is manually done. And uh, for the data that is there on the open source, it is time consuming, and it requires a lot of, it's not cost effective also, especially when you're dealing with the healthcare data where you require an expertise like radiologist to annotate your data. It requires a lot of specialized expertise, and they are very resource limited. uh, when you're dealing with healthcare data, it's very common that patients' records are not given to the third party to annotate because they are very sensitive data. It is time consuming, of course, when you're dealing with speech recognition kind of task and you want to get the transcription of that. Uh, as mentioned, it's very time consuming. Like, for example, transcribing speech can take 400 times, as mentioned here. Uh, can you move to the next slide? Yeah, when doing the hand labeling, it was like an old method. Right now there are new methods. The problem that was there is, for example, for name entity recognition, you have different annotators annotating on the same data. So you see the each annotator might find different number of entities in the same text. So, and also there is data lineage that the author talks in the chapter. So it is a good practice to keep the track of origin of each of your data samples as well as its labels. So uh, this is mainly required when we have like a model that we have already trained on like 100K samples, and now we want another millions data samples that to be trained on. uh, so the reason is that new samples were, your model not might not perform well on the new data, because the annotator who labeled the data might have less accuracy than to the original data. So this is the reason then we have to go with a technique called data lineage. Can we go to the next slide?
Um, machine data lineage is a technique. It's just, yeah, but we can
It's just a
discuss more about
practice.
it.
Yeah.
Yeah.
Yeah, like it says it's a technique known as data lineage. Yeah, so yeah. Yeah, talking about the strategies to address the, can you go to the previous slide? I guess we missed one. Yeah, so natural labels is an effective alternative way of dealing with hand labels, because Google Maps, ETA predictions, stock predictions, where you always get um, data from the user, so you can use that for your use case. I will talk about new methods along with the manual, uh, human labeling and natural labels. The new methods that you can see are supervised learning way of getting the labels, or semi-supervised learning, or natural language supervision. So in semi-supervised learning involves like training models on pre-text tasks, where a supervisory signals are generated from the data itself. So we don't have to rely on external human provided labels. So a self-supervised learning in an example would be like word embeddings, autoregressive modelings like GPT, or mass language modeling like BERT is one such example. And natural language supervision, we can take an example of clip model, which is trained on 400 million image text pairs to learn a joint embedding space between the image and text. So the main goal to learn the representation that can perform well on the variety of vision language tasks. So this can help us leverage in semantic information in language, in natural language. Yeah, these are some of strategies that are mentioned in the chapter, to address these labeling challenges. There is weak supervision, semi supervision, transfer learning, and active learning. So these are different strategies. Like weak supervision is like you can use any programmatic heuristic, you can generate labels instead of using hand labeling, because if it isn't feasible. You can use semi supervision, as I mentioned about word embeddings. Transfer learning, it will utilize a model that is trained for different tasks, and you can use the same learning that is need for extensive label in the new task. And active learning is another method where you can selectively label data that the model deems for more informative and improving efficiency and effectiveness.
All right, so I'll quickly talk about data augmentation and class imbalance. Um, so perturbation is typically used in computer vision. Let's say if you're building like an image classifier and you want to build some model that is like resilient to small perturbations, like also called like noise. So what you do is you augment your data by using things like rotations, zoom, or cropping. And you can also use like the generator network of a GAN to produce synthetic data, like indistinguishable from like genuine data. Um, and then another kind of data augmentation is data synthesis. So um, here I have some NLP related examples. You can use the simplest way is to use like templates, where you'd have like let's say you have a sentence with a company name. You can replace this company name with any other company name, it won't change the most likely won't change the label for your sentence. You can also use back translation. So you could translate the sentence in French and then translate it back to English. You'll get a different sentence, but it will have the same meaning. Or you could directly use a paraphrasing model. And generative models can also be used to, like LLMs can also be used to generate synthetic data. And I guess that's true also, and for computer vision, right? You could use a diffusion model to change, like let's say some like high level semantic attributes, right? Like the techniques that I previously mentioned, they won't, like if you have like an animal species and a scene, they won't able to change the species of that animal, but with like a image to image diffusion model, you could achieve this. And yeah, and also yeah, you can use LLMs to change the meaning of a sentence while preserving the label. And these techniques can be useful. Let's say if you have like very few samples for a minority class, and you'll typically want to do these kind of use these kind of data augmentation techniques. Next slide, please. Yeah, so talking about class imbalance. So for if you like training a classifier, you want to look at some losses like class balance cross entropy loss or focal loss. If you have like extreme class imbalances like focal loss, will probably be more effective because it will like dynamically focus the training on like very hard to classify examples. But in case they were like moderate imbalance, you could get away with weighted cross entropy. And then when you're gonna like perform the evaluation, you can't like use like accuracy, right? Because it just won't work. So you'll have to use things like F1 score if you have like classification threshold, or things like the RC curve or the precision recall curve. You might want to you might ask yourself like between RC or the PR curve, which one should I use? Typically, if you facing like a highly imbalanced data set, I'd go with the precision recall curve. It's usually a better choice. But you could use RC if you have like if you like false positives and false negatives have like roughly an equal cost. Yeah, next slide.
Yeah, so let's just try to wrap up the presentation soon so we can get the discussions.
Okay, yeah. I will try quickly go over the remaining slides. So in the remaining slides, we just try to see how what we have read is relevant and what might have changed. So as you guys are like you guys might be already aware or familiar with the stage in the LLM training, like there is a pre-trained foundation model, and then that foundation model needs to be adapted to some specific task or domain specific task. So there is fine tuning, and that fine tuning can happen through unsupervised fine tuning or supervised fine tuning, or in some case you may just do reinforcement learning with human feedback, or in most of the case it's the supervised fine tuning is followed by some sort of alignment to a preference or to certain behavior that you want to do. And there is also another way of adaptation, which is the in-context learning. And a good example for that is RAG, where you have prompting ways of adapting a pre-trained large language model. And of course, the next step that follows to all the different ways of adaptation is evaluation or evaluating those adapted large language models. And so I gave that just to give you some idea, or just to use it as a quick refresher. So pre-training basically is that initial step where you use a massive corpora to train the large language model. And the corpora includes like this image depicts, you have different types of sources. You have code, like social media, Wikipedia, so many publicly accessible content on the internet. And of course, with such kind of content comes a lot of issues, like there is bias, stereotypes already in the data, and other things which definitely will impact the model performance or quality. So those are some of the consideration you have to take into consideration when you are going about training your own or training a pre-trained or a large language model from scratch. So because of this, it will require a lot of cleaning, and then it's recommended to have some sort of diversity in your data. Like if you have more than one category, it will always result into some better model quality. And those are some of the steps that are included as part of the pre-processing, which I think are a bit peculiar to large language training. Of course, some of them are done in other cases also, but here, like after data is collected, there are a couple of things you need to consider when you are collecting data. For example, privacy and legal compliance is one of the things. If you are going to scrape the internet, you might be interested in making sure you are not violating any compliant or copyright issues. But once data is collected, it goes through some filtering, and filtering can happen through humans, or it can also be done through it could be done through some heuristic based, or it can also be done through some classifier. And those have their own implications in terms of what kind of bias and other things can be perpetuated by those filtering steps. Then, of course, once that's done, then there is data deduplication. Once you have all this, there are different ways of deduplicating your data. And then that has a lot of benefits. And some of those benefits are, it can impact the performance and the memorization, but the like tendency of that large language model is also reduced by the data deduplication step in the pre-processing. And then the remaining steps are to standardize the data. And then, for example, if you have a very complex Chinese, changing it to a simplified version is one of the standardization that you can do. And then last is to clean up and then do some human evaluation to make sure everything looks good before you start training your data. And so one thing that I want to highlight here is in the previous discussions, or what we read in the book, we talked about different ways of sampling, but those still apply. Like there are a lot of research, or there are a lot of practices that use a very simple random sampling of the test data. But especially now, as large language models are getting bigger and bigger, that's not so cost effective, and a lot of research are happening in terms of making data efficient LLMs, and that's done by having really good sampling method where you don't have to use all the data but still have really good performance. So this is one research which basically talks about coverage sampling and then some quality score sampling, where you have some heuristics which gives you some score, which scores your samples, and then based on those scores you will be selecting few samples that are having higher score, and those will be basically ways of scoring. And this at the same time also reduces any imbalance you might have in your data. For example, the random sampling that generally ignores unbalanced distribution in your data can be mitigated by, one example in this paper was cluster clip, which starts with a cluster sampling, and then it's followed by some clipping of the other represented samples. So this is just to correlate with what we have seen before. And then the next step, like I said, is fine-tuning. And then fine-tuning basically is to further train your large language model on some curated data set to adapt it to a certain task, or to have some domain-specific task. So there are different types, like I mentioned earlier. There is supervised fine-tuning. And then the common example is the instruction fine-tuning, which generally follows the pre-training stage, which basically helps the model to be adapted to a specific task or to question answering kind of state. And then, of course, there is the preference alignment stage, which follows that. So one consideration that I want to share here is early large language release like T5 and NT5 were going through a transfer learning or full model fine tuning, but starting GPT-3, I think new ways of fine tuning started to arise, like parameter efficient fine tuning, which is cost effective and then results into less complex and less compute intensive models, and those are the preferred way of fine tuning now. And there is also another paper that I found that also reduced the human cost associated with annotation with self-play fine tuning, which is basically it's kind of how the AlphaGo was trained. So the model will be playing with itself to generate annotations of the data that's going to be fine-tuned down. And then this is also some thing related to sampling. So we covered the active learning in the book, and active learning is preferred because it can give you an efficient way of leveling, but in the context of large language models, it can be a bit expensive because you have to retrain the model, and then also inference is done for every byte. So this paper pointed out that you can do some experimental design, and basically what they were proposing was you can treat the labeling as some sort of experiment, and then based on that you will have a better labeling strategy. With that, you will have low cost and better level efficiency as compared to just random sampling or even active learning. And then so those were the different types of stages. But another thing I also want to cover is bias. Of course, we see bias in other like in traditional machine learning, but in large language model training, bias is one of the big problems because you rely on a massively collected data which is very prone to bias and other stereotypes. So treating your data for bias is one of the things. Even there is a step that you can do in your fine tuning to just fine tune your large language model for bias. But it also presents a new challenge of class imbalance where you have some overrepresentation of certain classes or certain stereotypes, and that can cause some class imbalance. But the previous sampling strategies I mentioned, which also can include some sort of semantic deduplication, all those can help you to mitigate those problems in your data. And then another paper spoke about even how some encoding steps that you have in your large language model can bring about some bias. For example, this study showed that in birds was associating disability with more negative sentiments because in that embedding space they were closely related. So that's how that model was trying to associate those things. And then the next thing is privacy. So privacy is also another concern, and there are a lot of adversarial attacks that can happen onto large language models, and the kind of attacks that can happen there is something called membership inference attack, where some people can try to get if some sample or some example was present in the training data, and there are also some other attacks where some people can try to extract the training data. This paper basically talked about how that can be possible, and they did that
I just
on
wanna
ChatGPT.
check. Yeah.
Okay, yeah. But yeah, so those are some reference that you guys can read, but that's in terms of privacy. And then, yeah, finally, this is where the current trend is heading. So specifically in this year and last year, all the boxes below the line are closed sourced, and the ones above are like open source. And then the blue ones are the pre-trained or foundational models, and the others are the fine-tuned. So there is a trend that's happening where open source and fine-tuned models are becoming a lot, versus the others are not that many. I think that's the last slide. Thank you.
Thank you so much. I think it's great presentations. So sorry that I rushed through the presentation because I just want to make sure that we have time for discussion, since training data today is a big discussion topic. Like there are a lot of issues and new techniques, new approaches. So I want to mention, like when we talk about a natural label. So a lot of models today are trained using natural label, though we might not call it natural label. For example, self-supervisions that language model use is like technically natural label, or for models like Clip is using like natural language supervisions, which is also like natural label, for example, because they use text that co-occur with images as the as a label. And also another is for data synthesis. I have seen that it's really, really exploded recently, and not just with more distillations, which is like the approach of using a model outputs to like train other models, but also like for like generated data for like training, evaluations, correct biases. So I have posted a few discussion questions in the on Discord. So okay, let's get to this discussion. I'm gonna break people into groups. And after that, we can come back here. Yesterday, I sent a message about me not able to like participate in the future discussions. So just let's discuss like how do you want to move forward from then. Okay, cool. See you, everyone.